Probabilistic Systems Analysis Assignment Help. For any help regarding Probabilistic Systems Analysis Assignment Help, visit https://www.statisticshomeworksolver.com, email support@statisticshomeworksolver.com, or call us at +1 678 648 4277. 1. The weight of a Prandtl parabolic pretzel, W, is a continuous random variable described by the probability density function. W0 F W equals W1. 0 W less than 1 W1 1 W less than 2 3 W 2 W less than 3 3 W W ounces 0 1 2 3. What is the probability that 102 pretzels, with independent weights, will have a total weight of more than 200 ounces? Find an approximate answer. 2. Your friend challenges you to a coin flipping contest. However, you know this friend. Problem. 2. Your friend challenges you to a coin flipping contest. However, you know this friend to be of questionable moral character. In fact, you know that he usually carries a weighted coin that comes up heads with probability 0.55, along with a fair coin. You demand that he flip one coin 1,000 times, and if it comes up heads more than 525 times, then you will play using the other coin. Assuming he uses the fair coin, find an approximation for the probability that you will think it is the biased coin. 3. On any given flight, an airline's goal is to have the plane be as full as possible, without overbook ing. If, on average, 10 cancel their tickets, all independently of each other, what is the probability that a particular flight with maximum capacity 300 people will be overbooked if the airline sells 320 tickets? Find an approximate answer. statisticshomeworksolver.com. Px K equals 1 2. 2e x equals 2 var x equals 2. A. Suppose we obtain 400 sections of pipe. Determine the value of a bound, W, such that the total length of the sections we obtain will be greater than W with a probability of approximately 0.841. B. Determine N, the number of sections of pipe needed such that the probability we 4. The length in meters x of each section of pipe we obtain is an independent discrete random variable with PMF, 1K. B. Determine N, the number of sections of pipe needed such that the probability we obtain at least 200 meters of pipe is approximately 0.841. statisticshomeworksolver.com. Solutions. 1. It is not easy to calculate the CDF of the total weight and the desired probability, but an approximate answer can be quickly obtained using the central limit theorem. We want to calculate P, S102 greater than 200, where S102 is the sum of the weights of 102 pretzels. The mean weight of a single pretzel is W equals 2. The variance of the weight of a single pretzel is. Thus we have statisticshomeworksolver.com. 2. The probability that you will believe the fair coin to be biased is the probability that the fair coin will come up with more than 525 heads out of the 1,000 tosses. Let S be the number of times the coin comes up heads, which is a binomial random variable, with parameters n equals 1,000 and p equals 0.5, so that E, S, equals 1,000 0.5 is equal to 500 and sigma s equals square root 1,000 0.5 0.5 equals 5 square root 10. Using the de Moivre-Laplace normal approximation to the binomial, we have 3. The probability that the flight will be overbooked is the probability that less than 20 of the 320 tickets will be cancelled. Let n be the number of tickets that are cancelled, which is a binomial random variable, with parameters n equals 320 and p equals 0.1, so that E, n, equals 320 0.1 is equal to 32 and sigma n equals square root 320 0.1 0.9 equals square root 28.8. Using the de Moivre-Laplace normal approximation to the binomial, we have statisticshomeworksolver.com. 4. The pipe sections have lengths that are independent random variables. The length of each section, she, has mean and variance both equal to 2. A. Given 400 sections of pipe, we want the total length of pipe to be greater than W with a probability of 0.841. With so many sections, the total length is well approximated as a normal random variable. As an initial guess, the probability is 1/2 that the total length is greater than 800, so the probability will be 0.841 for some W that is smaller than 800. Define T to be the total length x1 plus x400. A couple of salient facts. T has an expected value of 800 and a standard deviation of 20 square root 2. The left-hand side of the inequality can be approximated as a standard normal random variable, and we want it to exceed W minus 800 / 20 square root 2 with probability 0.841. That happens if. Note the change in sign of the numerator, a change that allowed the use of a published table for phi, solving for W yields W equals 772, which is a bit less than 800 as anticipated. B. Now we want the number n of pipe sections such that the combined pipe length is at least 200 meters with probability 0.841. First, a rough guess. With 100 sections, the expected length is 200 and the length's distribution can be approximated as a normal random variable. statisticshomeworksolver.com. The left-hand side of the inequality is a standard normal random variable, and it exceeds the right-hand side with probability. Therefore, the length is at least 200 meters with probability 1/2. With more than 100 sections, the length will be at least 200 meters with probability greater than 1/2, so we anticipate an answer greater than 100. Note that the series x1 plus xn has mean 2n and standard deviation square root 2n. Setting that equal to 0.841, we obtain. Squaring and using the quadratic formula yields n equals 108. This time the initial guess was more than a reassuring check. It was essential to point to the selection of the positive solution from the quadratic formula. statisticshomeworksolver.com